Assalamualaikum warahmatullahi wabarakatuh. Sebelumnya saya mohon maaf karena ini pertama kali saya mengikuti seminar. Di sini saya akan mempresentasikan artikel saya dengan judul Sandwich Composite with Coconut Core, Fiber Core, and Polyester Resin Skin by Compression Molding System. Introduction. Coconut plants in Indonesia in 2021 are 2,777,530 tons, and the area of coconut plantation is 3,364,997 hectares. The large number of coconut production result in an increase in coconut core weights. Coconut plants are versatile plants or plants that have high economic value. Coconut core fiber contains chemical constituents, namely cellulose 37%, hemicellulose 0.15%, and lignin 14.2%. Composite is material made from two or more constituent materials with very different physical or chemical properties, which when combined will produce materials with different characteristics from each component. Composite made from natural fibers are a promising alternative to synthetic composite. One of the natural fiber to substitute synthetic composite is coconut fiber. Research methods. Procedure. Sandwich composite were composed of two skins with a core in the middle. The core manufacture of sandwich composite was carried out using the room temperature compression molding method. The ratio between fiber and resin in the core was 15%, 85%, 20%, 80%, and 25%, 75%, with variations in core thickness of 4 mm, 6 mm, and 8 mm. The use skin 100% using polyester resin. Specimen are left for 12 hours. After drying, the specimen was opened and removed from the mold. The next step was to glue the core the composite skin using polyester resin. The two skins were glued between the cores, then allowed to dry in the room for 12 hours. After drying, the sandwich composite is cut according to the predetermined ASTM standard size. The specimens were tested for mechanical strength, including the standard tensile strength of ASTM D 638, standard bending strength of ASTM D 790, and impact strength of ASTM D 256, and well as water absorption. Result and discussion. Tensile strength. The tensile strength test aims to determine the strength of the material against tensile forces. The highest tensile strength value is found the volume fraction of 20%, and the core thickness of 8 mm is 32 megapascal, while the volume fraction of 15% with a core thickness of 4 mm gets the lowest tensile strength value of 14 megapascal. However, the volume fraction 25% for all thicknesses, the strength decreases. This shows that increasing the percentage of the volume fraction of cocoa fiber does not always affect its tensile strength. All samples are known to have met the standard value of Indonesian national standards. Bending strength. The purpose of doing the bending test is to get the bending stress value of the test material. The highest bending strength is found in the volume fraction of 20% with a core thickness of 8 mm of 95 megapascal, and the lowest bending strength is found in the volume fraction of 15% with a core thickness of 4 mm, namely of 26.25 megapascal. With the addition of a volume fraction above 20%, there is a decreases in bending strength. This is because the amount of resin decreases along with the increase in the volume fraction of the fiber, so that the bending capacity of the fiber decrease. The bending test value obtained has met the Indonesian national standard, which the minimum value of the Indonesian national standard is 8.0415 megapascal. Impact strength. Impact testing was carried out to find out how much energy the coconut fiber sandwich composite could absorb. The highest impact strength is obtained at 20% volume fraction with a core thickness of 8 mm, which is 0.085 joule per square millimeter. Meanwhile, the lowest impact strength is at 15% volume fraction with a core thickness of 4 mm, which is 0.039 joule per square millimeter. However, the volume fraction of 25% with the same core thickness experience in decreases in impact strength. The decreases in impact strength is possible because the mixing between the fiber and resin is not evenly mixed. As a result, the addition between cocoa fiber and polyester resin is not good. Water absorption. The water absorption capacity equation is to show the ability of the coconut fiber sandwich composite board to absorb water after soaking for 24 hours. The volume fraction of 20% with a core thickness of 8 mm has the lowest water absorption capacity of 0.25%. This is because the 20% volume fraction specimen with a core thickness of 8 mm has only a few cavities or empty spaces on the left and right sides of the core that can accommodate water between the particles. The top and bottom of the specimen are glued with skin to close the pores and the composite board to so that it can withstand the rate of water entering the composite. Scanning electron microscopy. The scanning electron microscopy test was applied to the samples that had the most optimal mechanical properties. The figure beside shows that a mixture of 20% cocoa fiber and 80% resin provides uniform fiber resin mixing, so that the bonding between the cocoa fiber matrices occurs optimally and the fiber layout is relatively regular, so as to produce the most optimal mechanical properties. Observation of the fracture surface of the coconut fiber sandwich composite can be seen in the following figure, which also shows that the cocoa fiber matrices have a good bend. This can be seen from the very few cavities or voids on the fracture surface. Conclusion. Research on the manufacture of sandwich composite from coconut core fiber and polyester resin with a skin layer has been carried out. Core fiber compression and core thickness proved to have an effect on mechanical properties and water absorption. The most optimal mechanical properties and absorption capacity of the coconut fiber sandwich composite were obtained a 20% volume fraction with a core thickness of 8 mm, namely the highest tensile strength of 32 megapascal, the highest bending strength of 95 megapascal, and the highest impact strength of 0.085 joule per square millimeter. In general, the characteristic of the core polyester sandwich composite with to skin have met the Indonesian national standard. Judging from the result of the scanning electron microscope test, the volume fraction of 20% with a core thickness of 8 millimeters indicates that the resin and fiber mixture were evenly distributed. Terima kasih.